Hello everybody, my name is Dmitry Podborsky and I would like to give you a short presentation of our demo paper with the title HTML5 MSE Playback of MPEG 360 VR Tiled Streaming. Oh, this is a long name, I'm sorry for the amount of acronyms we used here, but however, it is how it is. Before I actually start showing you the demo itself, I would like to explain what is happening behind the scenes, because it's a bit difficult to see if you just look into the demo. And so what we did here is we implemented one profile of a certain MPEG specification, and in this case I'm speaking about omnidirectional media format specification, which is the first specification from MPEG Immersive project. And in particular we implemented this profile here, so which is HEVC based viewport dependent video profile, and this profile allows us to stream multi-resolution HEVC tiles. It's shown here on the client's on the server side. We store different resolution of tiles, so we tile the image and we store different representations. And on the client device, the client, in this case the browser, downloads only high resolution tiles for the certain viewport orientation. Everything else is in low resolution. Altogether is 4K image, which means 4K decoder can be used. Unpacking is done in the renderer, so at the end the resulting image which is shown to the user is of higher resolution than the decoded image. And the nice thing about it is that a single video is decoded at the end and not multiple for each tile separately, which is a nice thing. And here is a short overview. I will not go into the detail here, you can read the paper, but I would like to speak about the media engine, because it basically solves one of the problems inside the browser. And what is actually happening here is that currently OMAF is not really supported by the web browser, so you cannot really just feed video element with MP4 OMAF data and think that a browser can decode the image. Unfortunately, it's not the case. And so what we need to do, we need to repackage to make it understandable to the browser, and this is what we implemented. So in JavaScript we received the segments. Basically the problem is in this HEVC2 tracks. HEVC2 contains extractors, which are basically combining those different tiles together into a single bit stream. And this is done in JavaScript now, and we will publish the source code so everybody can see how it's done in order to realize that. And yeah, the repackaged segments can then be fed to the MSE source buffer, and the browser can finally decode the video at the end. The rendering part of this demo is using regionalized packing information from OMAF, which is stored also in the MP4 file. And this is basically telling the renderer how to process the image, how to unpack this backed frame back to cube map. And this is in this slide just shortly demonstrated how it's done to put it back on the cube. And there's additional metadata here allowing us to select on the dash level the right adaptation set while we are running the streaming session. Okay, let me explain it a little bit more detail while I will show the implementation itself, and then we can see how it works. Okay, let's now move to the demo itself. So you can see here, this is just a simple web page, because it's all JavaScript developed for the browser, obviously. So we are right now on Safari browser version 12.02 on macOS, obviously. So we need to use Safari because HEVC is not widely supported by all browsers. So Safari is fortunately supporting HEVC, and the website itself is located at the CloudFront distribution. Let me show you here. We have a bucket on Amazon S3 bucket, basically, where the website is located, and there's also the content located, and we have a CloudFront distribution for that bucket. And this is what you see here. Unfortunately, just updated the manifest file, but usually you can just load manifest if you from the predefined sources. In our case, I have to use the magic of copy and paste and load our sequence. And then after it's initialized, playback is paused. I painted low resolution tiles red so you can see them, and then we can see how fast they disappear when we play around with certain parameters. And so we can start our playback, and then we can navigate through the scene with the mouse. We can go into the full screen mode, move around, and so on. So you can see it takes a bit of a time until the low resolution tiles disappear completely. And we can also actually zoom in, navigate, and so on, so all supported. We can show some debugging information. So you can see inside the cube, rendering tiles, and so on. You can also limit the buffer, so you can say you buffer not too much, so the tiles are now disappearing a bit faster than before, because now we don't have too much buffer. Obviously, if we decrease it even lower, then at some point the network start to break, so it's always a trade-off between the buffer size and in this case. Okay, so you can see the performance of the renderer here, so it's rendering is not an issue here. And yeah, so this is basically what is happening, how it works, and yeah, the whole repackaging process works in the browser in real time. Let me maybe first also show you some additional things in our local server. For example, such thing as guard band. If we don't use any guard bands, what happens then? So I load this image, for example. There are now no guard bands are used. I described it in the paper as well, why guard bands are important. And so you obviously can see if we don't use any guard bands, there are some artifacts. So we see seams between the tiles, which is not a good thing. Therefore, we need guard bands. So all the content itself we prepared here is using 2 pixels of guard bands, and this is sufficient enough to remove all visible artifacts. You can always reload the source. In this case, no red regions are shown, so as you can see, no red tiles are visible here. So the idea is actually to create the content in such a way that the user never sees low resolution tiles, and if it sees them, then it's not too much of a disturbance for a short time. Yeah, so this is the demo itself. So maybe or else can I show like maybe what's happening behind the scenes on the network when we load the web page. Now nothing special happens, so we are right now not on CloudFront, but just to show, if we load what is actually it's not coming from this is not coming from the memory, so it's requesting basically all the tiles, and it's also requesting the extractor track, and so all of those are then merged into one file, and then this file is then repackaged. And maybe I can show you how the repackaged file, so basically how one decoded bitstream looks like. For example, I can extract here one bitstream and play it. Just yeah, so this is decoded by the browser and finally rendered using regionalized packing. As you can see, the door is right now in high resolution here. Track, for example, track 60, and run the same. So you now can see the door is now in this location here. So this would be the different orientation of the viewport. And this is what actually rendered, decoded by the browser, I'm sorry. Yes, thank you very much. So I hope you liked the demo, and yeah, have a nice day.